Good morning and welcome to Blockchain Week. This morning we have Mance Harmon, the CEO of Hedera Hashgraph, and he will be speaking on open source decentralization and shared worlds. Over to you, Mance.
Okay, thank you. Thank you so much for having me here today. I would like to spend some time talking about what we viewed as the requirements were and are for building a public distributed ledger, a layer one platform that addresses the needs to take the industry mainstream. So what are the problems? What prevents the industry from going mainstream? And then what have we done to try and address those obstacles to going mainstream? What are we doing today? How are we different than the rest of the market? And then talk about what the future might look like in terms of distributed ledger technology and the creation of shared worlds or shared environments that are decentralized in the way they operate and how they work, and what might that look like as well. So when we think about the problems, going back to say 2017, we think about the problems that the earlier generations of consensus algorithms and platforms had. Number one, everyone understands that they use enormous amounts of energy. They're proof of work blockchain is terribly inefficient when it comes to energy consumption. They have very low processing speeds. Number of transactions per second is very low. The combination of those two things results in very high costs associated with using the platform. And because the tokens that are used to pay those costs float on the open market, in the way in which they're used, the costs are very unpredictable, which is difficult for anybody that's building an application, has to use the services of the network, but can't predict what those costs are going to be associated with the services. In other words, the cost of goods of the service or product that's being built, the DApp. You need to be able to predict that, and it's difficult to do so. Security vulnerabilities, of course, if you're going to be building mission critical real world applications on top of this public DLT infrastructure, then security is paramount. You can't afford to build it on top of a platform that may go down for days or longer. And then what happens over time in terms of the centralization of the nodes in the network and the processing power of the network when putting transactions into order? Is it the case that there's this natural tendency for the hashing power, if you will, to become increasingly centralized over time and sort of eliminate the benefits of having decentralization in the first place? So we viewed, to address all those concerns, we said from the beginning, let's create a network that's highly performant. Today, Hedera can process 10,000 transactions per second, as opposed to, say, 7 for Bitcoin or 15 for Ethereum. Of course, Ethereum is trying to address this in Ethereum 2.0. They're wanting to increase that from 15 TPS to something substantially higher. Security, what we have is an algorithm called Hashgraph. I'll talk more about that in a moment, that has a set of properties that objectively, in sort of a mathematical sense, achieve the theoretical limit in terms of what can be achieved in terms of security of the network. It's something called asynchronous Byzantine fault tolerance. It's not leader-based. For those that know about consensus algorithms, it's proof of stake. It doesn't use proof of work. Not the algorithm, but the network doesn't use proof of work, as opposed to it uses proof of stake instead. Stability. If you're building an application on top of one of these public networks, you have to know that the network is not going to fork, that the application is going to run on a stable piece of infrastructure. I think the easiest way to sort of demonstrate this is to hypothetically imagine that you have an instance of Linux, an operating system running on a computer, a PC, a server, and you're running your application on that server. Now, let's extend that to assume that there's a whole community that is deciding whether or not to take that server and make a clone of it and create two servers that now are competing with each other and have different governance bodies, but your application gets forked along with it. Your application is now running on two separate individual servers, and your client software has to connect and decide which to connect to, and the state of your software diverges. It's chaos. No one would ever seriously consider doing that. But that's exactly the problem with having decentralized networks that are operating systems in some sense, and they can fork. Some number of the nodes in the network can become disgruntled. They can make a snapshot of the state of the network and go create a competing network, and all of those applications go along for the ride. You just can't, that's not tenable if you're wanting to build a serious application on one of these networks. Governance, the body that makes decisions on the product roadmap, the features that are going to go into the roadmap, the treasury management features that are associated with the decisions related to treasury management, decisions related to regulatory posture, et cetera, et cetera. You're going to want strong governance that you can trust to do a good job over years and over decades if you're building your business on top of this global platform. And then finally, sustainability. It matters. The fact that the first generation proof of work networks use so much electricity and energy generally is a problem. And so we want to build a platform that has an incredibly low carbon footprint relative to those. And that's what we've done. So let's talk about the technology. It's not blockchain. It's a consensus algorithm that's called Hashgraph instead. Blockchain is a term that represents both a data structure, a chain of blocks of transactions, as well as a consensus algorithm for the nodes in the network, the miners that are running the network, a way for them to come to an agreement on which block to put on the top of their local copy of the blockchain, and a way for them all to choose the same block to put on top of their copy of the blockchain so that their blockchains can remain consistent. It's very slow. It's very expensive. It's fantastic in terms of what it did in opening the market to what it is today, but Hashgraph improves on it by orders of magnitude. It achieves the theoretical limit of what can be achieved in terms of security. Again, something called ABFT, or asynchronous Byzantine fault tolerance. All that practically means is that we don't have to make unreasonable assumptions about the types of attacks that might be levied against the network. For example, we don't have to assume that there's no such thing as DDoS attacks, because of course there are DDoS attacks. And if you have a leader in your network, it's a consensus algorithm that uses leaders to coordinate the nodes in the network, well, then you can attack the leader with a DDoS attack. It's leaderless, and it achieves ABFT as a result of that. And because it can process so many transactions per second and it doesn't use proof of work, it is incredibly inexpensive and efficient with respect to energy consumption. The platform itself, this picture here, I'm sorry, you don't see the picture. So we have a consensus algorithm that is run by the nodes in the network, and there's a governing body that provides governance of that of the platform. The platform itself has three services: a consensus service, a token service or tokenization service, and a smart contract service. Those three services, in combination with one another, make it possible to build arbitrarily complex dApps, distributed applications. And just to give a sense of the types of dApps that are often built on top of Hedera, it's data integrity related applications. Tokenization generally is used. Decentralized identity related applications, supply chain, payments, and the users span individuals, enterprise, governments, small and medium businesses. It's a general purpose public network that has the fantastic properties that I've described. Well, what about governance? Let's talk a little bit about the theory of governance, if we can. So when you have a governing body, you have to make some decisions about how to organize it. And that depends, the decisions, the answer to the questions you have to ask depends in part on how complex the decisions are that the governing body is going to have to grapple with. For example, if we wanted to, let's think about a sovereign currency. You know, different countries have different ways of managing those currencies. In the United States, where I live, there is a Fed, and the federal bank makes decisions about what the Fed policy should be with respect to the dollar. Now, we wouldn't seriously consider making it possible for everyone that owns a dollar to be able to vote on the policies associated with the dollar, because the decisions are incredibly complex decisions that are being made associated with policy. You need experts making those decisions, not anyone that holds a dollar. And so from that respect, you have to make decisions, or when deciding on your governance structure, you have to think about the complexity of the decisions that are being made. In other words, you wouldn't want a democracy. You wouldn't a democracy model where there are lots and lots of decision makers for very complex decisions. For really simple decisions, sure, full democracy makes perfect sense. For highly complex decisions, probably not. You would either want to go with an expert council, or you could go with a dictator. Dictator can make complex decisions if they are smart enough and have the background and advisors to do so. But you also have to weigh that against how much trust you want to put into the governing body, the decision makers. If you put the decisions in the hands of a dictator, then you're trusting the dictator not to become malicious or do bad things. There's a lot of trust placed in the hands of a single person. You can decentralize that trust by increasing the number of decision makers. Of course, the full democracy, there's a lot of trust, decentralized trust in a full democracy, but there's the trade-off in the complexity of the decisions. If you have an expert council, which by and large is the way the world of decentralized or distributed ledger technology works, these public networks, including Hedera's public network, has a group of experts, generally speaking, that are making the decisions. Now, our governing body is different than others that you might have seen. Others will have a group of core developers that are primarily making all the decisions, including not just what goes into the code base in terms of features, but also in terms of governance. Maybe there's a single foundation that is making all the decisions related to governance of prioritization of roadmap, legal regulatory posture, pricing, where pricing is appropriate of services, et cetera, et cetera. If you don't have the ability to enforce the decisions that the governing body is coming up with, well, then you've got a problem. That results in weak governance. The experts that are making the decisions can't enforce those decisions. And so everything sort of slides into anarchy, where nobody is really making good decisions. You need to be able to enforce the decisions that are being made by the governing body. Hedera has a governing council, and it's by design meant to be the most decentralized governing body of any of the public networks. The governing council is made up of global enterprises. There are 26 today. These are some of the largest companies in the world, include names like Boeing and Google and DBS and LG and Tata and Nomura, Magalu, IBM, on and on. They're intentionally chosen to span industries. They're not all from the same single industry. They're not a bunch of banks, not a bunch of tech giants. They're meant to span industries or market segments, and they're chosen from different geographies. They're meant to be representative, bring to the table an understanding of the use cases that are important for the entire global ecosystem, right? So they are a governing body in the sense that they make the decisions, the categories of decisions that I've described. They govern each company has a single vote, and they participate through committees in making fundamental decisions about the network. Where there's a legal and regulatory committee, they make decisions about regulatory posture. There's a technical steering committee that has technical experts from the various members of the council, and they set product roadmap, et cetera, that sort of thing. And so it's a very different type of governing council than than any of the other platforms in the market today. I haven't seen anything else like this in the market today, and it's unique in that regard. I touched on the fact that Hedera uses proof of stake rather than proof of work. That is important when we think about sustainability and being green. You know, we care about not wanting to use a lot of electricity or energy more generally when operating the platform. One of our council members is University College of London, and UCL has a Center for Blockchain Technologies. They did a study where they looked at a large number of the layer one platforms and they compared them. In fact, you can go and download this study if you're interested. It's on our website, the hedera.com website, where they compared Bitcoin and Ethereum 2.0, the new version of Ethereum, assuming it is deployed, Ethereum 2.0, Cardano, Polkadot, Tezos, Algorand, and also the Visa network, just as a baseline, if you will, as well as Hedera in terms of the number of watt hours per transaction. And it turns out that Hedera has the least energy usage per transaction of any of those platforms by a long shot, by orders of magnitude in most cases. And so Hedera is not just a green, energy efficient global distributed ledger platform. It's also working with organizations to build out the ESG ecosystem in general. In fact, I just got word less than an hour ago from the HBAR Foundation, which is a separate organization from Hedera that's chartered with helping to foster the growth of the ecosystem, the Hedera ecosystem generally. The HBAR Foundation has created an ESG related fund. They funded it with $100 million. And they just announced this morning that their first grant in Australia has been announced. And it's time. I want to make sure I get this correct. It's Timeless. So Timeless is a public company. It's traded on the ASX there. And they are now working with the HBAR Foundation to build out some of the necessary infrastructure for the green economy generally. And there's a press release. If you're interested, go and Google it. I'm sure you'll find it. And Timeless is now working there in Australia to help grow this capability within the Hedera ecosystem generally. So when we think about adoption and the growth of the distributed ledger technology industry generally, we might ask, well, where are we? Where are we today? I think that it's fair to say that we're sort of crossing the chasm. You know, if you think about Gartner's maturity charts and that sort of thing, it typically starts with the innovators, followed by the early adopters, you know, the tech enthusiasts, and then the visionaries that go and try to build a new technology category. Well, we were the tech enthusiasts that created a new layer one protocol. I would say that a large number of our council members were also tech enthusiasts and also visionaries. They are the ones that began the earliest steps of adopting and agreeing to participate in something like Hedera. To cross that chasm, you have to do the work of making it easy for the early majority, and then following that, the later majority, to adopt the platform. And that's what we've spent a lot of time doing. We've spent the past couple of years adding tools and services that make it increasingly easier and easier to build out distributed applications on top of these global networks. As an industry, we have, and certainly we have as Hedera as well. And where are we today? I think we're in the chasm. I think that there are a lot of POCs. There are some production ready use cases that have been deployed even by some of our council members. Toco by DLA Piper is a tokenization issuance platform. It's been in the market now for some time, and they're having good success with that. Of course, payments and payment related use cases were one of the earliest use cases for the technology, and those are still by and large in the late POC stage, with enterprises making plans to productize and go to market. And I think that's generally true. I think that a lot of, certainly when it comes to the enterprises are in late POC stage. Some are more mature and closer to market than others. The Hedera network has logged 2 billion, I think. We're over 2 billion transactions now since opening the network generally in September of 2019. That's an enormous number of transactions, more than anyone else in the market. But most of those transactions are not by enterprise. They're not by large companies that have completed the productization of their products and gone to market. It's by smaller organizations, still businesses primarily, businesses that have found a way to take advantage of the throughput that Hedera offers at 10,000 TPS and not be restricted by 10 or 15 transactions per second, but nevertheless, still small and medium businesses. We're right at that edge of crossing the chasm, and I think that's what will happen in the next couple of years. So I'm going to do something that's kind of unexpected. I am here with Leeman Baird, Dr. Leeman Baird. He's my co-founder. He's the inventor of Hashgraph. And I'm going to ask him to take a few minutes to talk about vision and what he sees as the vision for shared worlds that can be enabled by this technology. So one moment.
Well, hello, I'm happy to be here with you. Thanks, Mance. And just very briefly, I would just like to mention what we're talking about, what our vision has been from the beginning, is to have these shared worlds. And let's just talk about that. People are talking about metaverse, and all sorts of things. But from the very beginning, we've said that our vision is to have shared worlds, to allow anybody to be able to kind of wave their hand and carve out a piece of cyberspace, to invite friends and other people to collaborate with them, to have this shared information, these shared things they're creating, shared things of value, and then to connect to other people. And so that's been our plan from the beginning. And so the idea is that a single person should be able to create on their computer information. Everyone can do that already. But to do it in a way that it's a local ledger of just one computer, but then they can invite others. And as others join, it creates a network right there on the fly. So this isn't even a public ledger. This is just, a private network, but very easy to create. And it is a world that they are creating together. And so they can create documents, they can play a game together, they can be jointly engineering something, they can be writing documents, they can be creating videos together, all the different ways they could just interact with each other. And then after they've done that, they should be able to invite other people, and other people can have the knowledge that it's reliable because it's a distributed ledger. It could be Hashgraph, which we are in the process of open sourcing. The council has voted to open source all of the software. Once they do that, other groups can do the same thing, and then you can connect them. And so we have something coming out this year called state proofs that will allow us to have communication between these little ledgers, these little shared worlds. So you have a little world over here shared by several people and a little world over here shared by several people, but have communication between them and have this cryptographic proof that when this group receives one of the messages, it truly is the consensus of this group. And that allows you now to do things like create a token of real value on Hedera, on a public ledger, and then to move it from ledger to ledger to even these little private ledgers. Or play a game on your private ledger that's all private and no one knows about it, but you periodically put the state onto the big ledger. So I've said things that sound sort of like L2s, like level 2, layer 2 things that work on a ledger. I've said things that talk a little bit about like interledger communication between public ledgers and even these little private ledgers and ad hoc ledgers that just come up on the spur of the moment. We will be able to communicate and share between them. And the key to that is to be able, of course, to have actual finality on a ledger, and then a cryptographic proof that this is what you got finality on, not just of the entire state, but of just little pieces of it, and to send that to another ledger and condense them. And so I think this is the future of ledgers, is to have them, blockchains, is to have them all interoperable in this way, where you can cryptographically prove that your balance on this ledger is a certain amount and prove it to another ledger, and then it can act on it. Or prove that you've wrapped up a coin and then you can unwrap it somewhere else. And then the idea is you could have a world, when we talk about metaverse, well, it's VR on top of this, but the whole thing is about the data underneath. And so the idea would be that you could have, instead of one company running one metaverse, one world, you have a million worlds, and they're all shared and they're all connected to each other. And they all have these cryptographic proofs to convince each other that they are saying the truth about what they truly think as a group, not just one computer saying it. And this is the future, interoperating with Hedera. Mance? Okay, come on back.
So just to finish up, I should have realized earlier that my audience, I'm talking here to Australia Blockchain Week, and I neglected to point out one of our council members, which is FPOS. So I'm sure you're all familiar with FPOS, and they've done some fantastic work in terms of micropayments, enabling micropayments using transactions on Hedera. If that's of interest, please go take a look. It's just Google FPOS and Hedera, and you're going to find all the details. So with that, I want to thank you all for your interest and appreciate it, and hope you enjoy the rest of the conference.